All right, hello everybody. So we're gonna go back in time a little bit, and we need to review some function analysis. All right. So we learned this way back in December, but let's just have a quick little review for today, and we'll build on it from this lesson tomorrow. Okay, let's take a look at this. For the first question here, and just real quick before when I ask a question, what I want you to do is before I show the answer, what I like you to do is try and write what you think you remember before I show it myself. Okay? So let's take a look at the first one. Here, if we have this, let's look at letter A. It says state all the x values for which a horizontal tangent line exists. So when you take a look at this graph over here, visually take your time, but where do you think, when will a graph produce a horizontal tangent line? So where will the horizontal tangent lines exist in this graph, and how do they occur? Okay, so notice for this, where are they? There should be one over here. There should be one over here, and there should be one over here at this point over here. And what's the idea between these three? Is there one over here too? Yes, there is. Okay. And what's the idea between these points? The idea is when the slope of the tangent line goes from positive to zero to like when the slopes of the tangent lines when the slopes of the tangent lines are zero, that's where you're going to have a horizontal tangent line. So we need to have a slope of zero. So notice what's happening here. Let's take a look. Imagine if we're having tangent lines. Look at the tangent lines that you draw here. Like if I drew a tangent line, this is one here, this is one here. Notice that these are all positive. But the second when the tangent line becomes horizontal, just like this, then we know that the slope of a horizontal line is zero. So then here, it goes from zero, so it's positive, 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 zero, positive, 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 zero, negative, 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 zero, negative, 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 zero, positive, positive, positive. Okay? So that's the idea for the first part. Let's take a look at the next one. Here, where will an absolute minimum occur, and okay, this should say maximum here. Where will an absolute minimum occur, and where will the absolute maximum occur on a graph? When will it exist? Right? So try and answer this question. Like where, and we didn't actually answer the question. It says here, state the x values for which a horizontal tangent line exists. What are the x values for which this exists? Well, here, at x equals negative 5, at x equals negative 2, at x equals 3, and at x equals 7, here we have horizontal tangent lines. Okay. Now, where would the minimum occur? Notice that what is the definition of an absolute minimum? It's the lowest point where a function is defined. So let's take a look here. Where is the lowest point on this graph where the function is defined? The lowest point is right here at x equals 7. And notice that what is f of 7? Do you have a value? And yes, what is f of 7? It is negative 5. So you see the function does exist, and this is the lowest point. What about the absolute max? Notice that at x equals negative 2, this is the highest point on the graph. And what is f of negative 2? Notice that when x is negative 2, the y value is 7. So notice that it does exist over here. Now here, what happens with a relative minimum and a relative maximum? How do these occur? So let's take a look at this question here. For a relative minimum and a relative maximum, the idea is when the slope Actually, let me pause the video and let me just make sure I get the right definition. 1 second, hold on. To have something like this, and for a relative min, you want to have something like this. And now notice what's happening here. Where are the relative maximas? Here, a relative maxima would occur. Let me get my pen. This would be a relative. This will be a relative max and an absolute max. But here, and that's it. It would just be this point. And the idea is the slopes go from positive to negative. So notice how, look at the slope coming from the left side. Notice that it's positive, 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 and then it goes to negative. So when the slopes of the tangent lines go from positive to negative, we have an absolute max. Notice over here, look at this. This is not an absolute max because the slopes are going from positive to 0 to positive. Okay? And notice, let's look at the slopes here. This is from negative, 0, negative. Now, where does an absolute min occur? When the slopes go from negative to positive. So you see here, this would be an absolute, this would be a relative min over here, and this would be a relative max over here. Okay, and yeah, and let's try and do the last page together, which shouldn't be too bad. What I want you to do is, looking at this graph, where are the horizontal tangent lines? Where would horizontal tangent lines exist on this graph? And what I want you to do is try and answer that question yourself just by looking at it. So notice, where would it exist? There should be one here, here, and here. So where are the horizontal tangent lines? At x equals, let's say, like negative 5.5, x equals 0, and x equals 5. Those are the horizontal tangent lines. Okay. What about an absolute minimum? Where would the absolute minimum and maximum exist over here? The absolute min, let's see, so absolute min does not exist because here we have an open circle, and remember, the function has to be defined. Let's take a look. What about absolute max? This one also does not exist because it's not defined at its highest point. Okay, what about for, let's take a look. How about relative min and relative max? Where would a relative min occur? Remember, the relative min occurs from when the slopes go from negative to positive. So here, notice that from this, what are the slopes of the tangent line? The slopes are negative, 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 0, positive. So here, this would be our absolute min. This would be an absolute min at x equals negative 5. And here, nope, not here, because they go from negative 0 to negative. So where would an absolute max occur? It would be here at x equals 0 because the slopes go from positive to negative. All right. Now let's take a look at this next question here. We're almost done. Here, okay. For this question, it's saying, for when is the graph positive and when is the graph negative, and what does that mean? Here, a graph is positive when it is above the x-axis. A graph is negative when it's below the x-axis. So let me just write that down. So here, when a graph is positive when f of x is greater than 0. It's saying that when the graph of f of x, when it's above the x-axis, when it's greater than 0, it's positive. So a graph is negative when f of x is less than 0. So notice, where is the graph positive? The graph is positive from everywhere from -9 to 3. So here, when is x positive? When x is less than, when x is, let's see. When x is less than -9, but also greater than 3. Oh no, because we forgot the union. Remember that at -5, the graph isn't above the x-axis, it's at 0. So for here, for when is it positive, let's take a look. We want to show everything between -9 and 3. But we're not going to include this point and this point here because the graph isn't positive, the graph is 0. So how would we do that? It would be, what is it? So it's -9. Oh yeah, we got to do it like this. -9, including -9 to -5, union -5 to 3, close like that. Okay? And this would be, this is for when the graph is positive. When is the graph negative? It's from 3 to 9 inclusive. So this is positive and this is negative. Because remember, at -5 and at 3, we're not, it's neither positive or negative, it's 0. Okay. And for the last one, when is the graph increasing and when is the graph decreasing? You have to look at the tangent lines. When are the tangent lines positive? When are the tangent lines positive? When are they negative? So notice over here, the graph is decreasing when? I'm sorry, when is the graph increasing? The graph is increasing from here to here. And that's it. The graph is only increasing from -5 to 0. And remember, we're not including -5 and 0 because what is the slope of the tangent line at -5? It's a horizontal, it's 0. So it's not increasing at -5. But everything between -5 and 0, it's increasing. When is the graph decreasing? The graph is decreasing from, let's see, from -9 to -5. So from -9 to -5. And also from 0 to 5. But then notice, you see, at x equals 5, it's not decreasing because the slope of this is 0. And then from 5 to 9. So from union 5 to 9. Okay. Let me zoom out a little bit. Okay. All right, class. Here it is. I know this was a little sloppy, not my best work, but what I'd like you to do is the delta math. Very important for you to actually like practice and review these things we did way back in the day. You really need to do your delta math, and for this delta math, I'm going to give a lot. I'll give like 10 questions because you guys really need to review. And hopefully, if you felt like you didn't understand, maybe I didn't explain things as much clearly here, I'll try and explain them more in our Google Meet, or maybe delta math could help you a little bit more. All right. Enjoy your day. I hope this helped.